afternoon and welcome to the lecture number 9, Other Application Client Types. What we've been looking at so far are internet applications that have been based on the web, which is fine, they're internet applications after all, but we've really only been looking at the server side of things. And what we're going to look at this afternoon is the client side. And we're going to take it a step beyond just assuming that we've got a web browser as our client. So we're going to look first of all at using some Java applications as the clients for internet applications, and then also look at JNNLP. Because we've been assuming that the clients out in the big wide world that are using or connecting to our internet applications have been web browsers, all we've done is only look at presenting the view for each interaction as a set of HTML instructions. So what we're going to do instead is consider what happens if my client is not a web browser but some other kind of client. In theory, we can use any kind of client that will interact with the application, so long as the client sends the correct type of request, so respects the protocol that's necessary for connecting and communicating with the server, and also sends the right kind of information. And as long as the server recognizes the request and all the information that's necessary is part of that request, then the server, our application, will continue to work as normal. And will therefore take the request, process it, and then send a response of some sort. And the client must process that response in order for the user to see the results of the request that was issued. So as long as the client that we introduce here, which is not a web browser, respects that request, process, response cycle, then we'll be okay. So what we're going to do is to use a Java application as a client and see what that means in terms of the programming of the client. So to communicate with the server, the client must send a request to the controller servlet, which of course is exactly what our HTML pages have been doing anyway with the HTML forms. And the view component is still responsible for formatting the data in such a way that the client is able to use it. Now, if the client is going to send a request, it has to be able to connect to the application. And so what we're going to do in our Java application is to make use of an HTTP connection, which of course is what the web browser does. It sets up a connection to the appropriate server on the appropriate port and passes in a request that is of the appropriate type. That type being determined by the protocol that's used. So if we're using an HTTP connection, that means that we're using the Hypertext Transfer Protocol. And so long as our client interacts according to the rules of that protocol, there will be no problem. And so we can send the request, including any parameters that might be needed. And then we can get the response by reading that connection's data stream. So the client will read the data stream immediately after sending the response and will then sit and wait until the application writes a response, and then of course the client can read that response. And of course that is exactly what a web browser does. We just don't tend to see that as the user. But now, as we're going to start writing our own applications, we'll have to think about these issues. Now, back on the server side for a minute. If we've got a web application, and it could have two types of client, an HTML client and then some kind of Java client, then we might decide that we don't want to have a standard response for all kinds of clients. For a web browser client, obviously we're going to need to output HTML, but for some other kind of client, the internet application could output, well, whatever we want it to. Plain text, XML, HTML, serialized objects, whatever you want. And that really is going to depend upon the client. So that now brings up an interesting scenario. How does our internet application deal with that? In this diagram, we have got essentially what we've become used to dealing with. A request comes in from the client to the controller. The controller works out what kind of request it is and then will coordinate the response by invoking the appropriate model and view components. Now in this example we're going to issue an include command to invoke update customer, which will change the database, and then the controller will invoke retrieve customer, which will extract the information from the database and set up a bean. Then when the controller forwards the response to the customer view, that customer view will pick up the details from that attribute on one of the sessions, on one of the scopes, response session or application scope, and we'll use that information and format it in some way, in this case using HTML. And that's for a single user transaction. But what happens if we have a different client type? Well, the client will still have to issue the same command as the web client, and the controller will basically use exactly the same model components to produce exactly the same bean. The only thing that changes is if this client is expecting plain text output, not formatted as HTML, then the application is going to have to distinguish between HTML output and plain text output. And basically that means rewriting that view as a different kind of view. Presenting the data or exactly the same data, but we'll be presenting it perhaps differently based upon the requirements of the client. So now, all of a sudden, our application is taking account of the client type. And we'll look in a minute at how to distinguish between our client types. And then having worked out which client type it is, well, there's no difference in terms of model and beans. We just have to work out which of the views to invoke. And then if we have a third client type, well, same story really. We just need a third view of the same data, but this time it's going to be output, for example, as XML. So you can see the pattern here. Depending on the client type, all we need to do is to change which view is invoked for that particular transaction. The model components don't change. The bean components don't change. And this is precisely the reason why MVC is such a useful thing. Because we don't have to change the bits that don't need changing now. If we'd got all the model and all the view and all the control bundled up in one servlet like we started off doing right at the beginning of this module, then we would have had to write 3 separate implementations of the model as well as the view and the control. Now, because it's all been separated out, we've had the separation of concerns that we talked about earlier on in the module. Now what we've got is a very nicely structured application that is extensible. It's flexible. It can deal with any kind of client. All we have to do is extend the capability of the application by adding in different views, and then change the controller by just basically setting up an extra option on the if statement. We'll see that as we get to it in due course. So the controller has to orchestrate the combination of model and view components. So what the controller has to do then is, dependent on the client type, is to work out which view to use. And there are various ways in which this can be done. One of the ways is to use a property on the request header for the HTTP request that is called user agent. And we can do this, or we can see what the user agent is, by calling request.getHeader and passing in the name of the property of the header, in this case user agent. And what that will do is return a string that gives us the user agent information that the client has set. And web browsers do this all the time. And for example, you might end up with a string that looks like this. And that tells you what kind of web browser you've got, and so on. Well, if web browsers can do it, then so can our clients, our Java clients. And so we can do things like set the header information to something that our application is expecting, and then the application can call getHeader from the request object and get the user agent information that the client set, and if the controller recognizes it, then it knows what kind of client it's got and can therefore invoke the appropriate view. So if we go back a slide here, what the controller will do is, having received this request, it can call the getHeader to find out what the user agent value is. And if it's one of the HTML things, it will invoke this view. If it's the plain old Java kind of client, it's going to invoke this one. If it's an XML client, it will invoke this one. So you can see really that the selection of view is going to be fairly straightforward. Just a little if statement that tests the value of the user agent property. So let's go and have a look at an example to see how this is done. Now what I've done for this example is try to simplify things really as much as possible. So if we take a look at the project for the internet application, I'm not looking at the clients at the moment, just the server side. We've got the web pages, and we know that our JavaServer pages go into that folder. And typically all we would have is the view and the error view JSP files that would sit directly under web pages. But what I've done is organized it slightly differently. I've got a folder that is called HTML, in which I put the JavaServer pages that we're used to dealing with. And then another folder that will have JavaServer pages that produce just plain text output. And another folder called XML that has JavaServer pages that output XML. And you'll notice, of course, that the files in each case are exactly the same, and there's good reason for that that we'll take a look at in a few moments. Therefore, all these files are going to do exactly the same thing, and they've been grouped according to what kind of output they produce. Now if we take a look, I'm just going to minimize that, take a look at the three views. This is for HTML, this is plain text, and that's XML. The first part in each case is pretty well identical, the first 6 or 7 lines. In this case, this is the HTML output. We've got the page directives. I'm doing an import here for enumeration, setting up or getting a bean that has been previously set up by the model component, and then we're storing a variable here called name and passing in the value as whatever the request parameter is for name. And we're doing exactly the same thing in all three options. So there's not really a lot of difference there. Where we start to get different, of course, is in the output of things. Because this is HTML, we're outputting this bit here, which contains all the HTML tags. And if I just scroll over a tiny bit, you can see that we're using a JSP expression to get hold of the value of name to know what kind of output to produce. And that's embedded in a whole load of HTML that will format that output so that it looks good on a web browser. On the other hand, if our client is expecting plain text, then all we have to do is to output the message as plain text. So there's no HTML tags or anything like that. But we've still got that that JSP expression, which is the same one that was here. Okay, so the same in there as in there. So in terms of the processing of the Java Bean, there's not really going to be very much difference at all between the three view types. It's only in terms of the way that that data is formatted that it's going to be different. And over in the third example here, where we've got XML, again, the first 6 lines are the same. Then we've got the XML, so we set up the DTD information, which in this case is defining the structure of the document. So what this tells us then is that the root element is called message response, and there's the root element, message response. And that this message response element consists of an element called message response that has one or more line elements. And a line element consists of a whole load of data. I don't propose to give you any information about XML and the way that it's structured and what all the bits and pieces mean. If you don't already know it, then you'll need to go and look that kind of thing up. So the output here has the root element, message response, and then we've got a line element with a corresponding end line, a line element with a corresponding end line. And then the data within that element is presented between the start and end element. Okay, so it's relatively straightforward to set up the output for different client types. So I'm going to close these now so that we can think about how the controller distinguishes between these. Now, this is where the organization of the views becomes important. Let's open up the controller. The first thing that the controller does is to get hold of that user agent information from the header that's on the request. And then we're trimming it and converting it to lowercase for the purpose of getting rid of all the superfluous spaces that might have been introduced, because we don't know how the programmer is going to do this. They might have put in an extra space or so at the beginning or the end, so trim gets rid of those. Convert it all to lowercase means that we don't have to worry about whether the user has typed the correct combination of uppercase and lowercase letters. And then, and this is where we're going to take advantage of our folder structure, we're going to set up a variable called viewPath, which will basically define the folder in which the view elements are going to be found. And that's going to be based on our user agent. So if the user agent starts with java-name and time app-text, then viewPath is going to be set to text/. Else, if the user agent starts with java-name and time app-XML, then the viewPath will be set to XML/. Else, in all other cases, we're going to assume that it's an HTML output, and so viewPath is set to HTML/. Having done that, we've now essentially taken care of selection of the view components. Because all we'll do now is whatever client we've got, we'll still invoke the model, and we'll still invoke either view or error view. But what we're going to do is prepend the name of the JavaServer page with the view path. And those of you that are observant will have already noticed that it hasn't been done in there. So we'll put that in. And when you download it, you'll need to remember to do that. So now, whether it be the view or the error view that is chosen, the view path, which was set up here, will determine which one we use dependent upon the client that we've got. So that's a very straightforward, very easy way of dealing with it. It does mean, of course, that we've got to duplicate all our view pages. That's inevitable. If you're going to handle more than one type of client, you're going to have to do that. And for the sake of organization and clarity and so on, organizing it into folders like this, I think makes a lot of sense. So that's the approach that I would recommend you use. So that's still all been server side. Let's think now about the client side. I'll save that. Let's take a look at this one. This is a Java application, just an ordinary Java application. And what I'm going to do is to run it simply for you to see what it looks like when it executes. So because our network is a little bit slow this afternoon, we've got to wait a few moments. But in a few seconds we should see a JFrame appear. That JFrame is going to be structured in this way, and most of the code in this class is all about setting up the structure of the graphical user interface. And what will happen, and we won't run this now, but when you download this and run it for yourself, you will need, first of all, to make sure that the server-side application is running. Then you can start your client, type in a name, or leave it blank, it doesn't matter which, and when you've typed your name and clicked on Submit, it will then send a request using the HTTP protocol to the server. Now, if your server application, your internet application, isn't already running on the server, then of course nothing's going to happen very much. But if you have got your server running first and then start the client, then you'll get the request accepted. The controller will work out what type of client it is and then send a response in plain text. And the plain text will then be displayed in this text area here. So what I'm going to do is just skip over the description of all the setup of the graphical user interface and just look at that interaction between the client and the internet application that occurs when this submit button is clicked. So all of that is set up for the graphical user interface. The important thing is this. When the submit button is clicked, this method here, get name and time from internet application, will be invoked. And that's the method here. And so this is really what we're interested in. So first of all, we need to know the URL of the controller servlet. So we can set up a URL object in that way. Then we can use that URL object to open a connection. And because we've got http:// that tells us that, or tells the open connection method that this is going to be an HTTP connection, and so that all gets set up automatically. We don't have to worry about all the protocol stuff. That's dealt with for us in the open connection method, and then the object that gets sent back that we store in con is of type URL connection. That is going to handle all the low-level detail of interacting with the server. All we've had to do is to say, this is the URL I want you to use, now connect. We need to give a bit more information though. We need to say, with this connection, I'm going to do some input. Well, of course we are, because we want to read the response that comes back from the internet application. Now, because this is going to be a post request, that means that not only do we open the connection using this URL, which contains domain and port information, and then some other information such as the application URL and the URL of the controller. If all we were going to do is a GET request, then we would have to make sure that we put in here a question mark and then name equals Graham, for example. And then if we had other parameters, then we'd have to say and age equals and then some value. Now that's sufficient for a GET request, and all we then have to do is to set doInput equal to true. However, we're not going to do a GET request. We're going to do a POST request. And with a POST request, remember, the connection and the data related to that are sent separately. Therefore, as well as saying the doInput is set to true, we're also doing some output, because we're going to have to write some additional information to the application. So that's set to true, and we're not going to use caches. Now we have to tell the controller what kind of client we are, and therefore that connection has got a method called setRequestProperty. The property we're setting is the user agent property, and the value we're setting it to is Java-name and time app-text. Notice that we've got some uppercase and lowercase letters in there, but because the controller is converting it all to lowercase, as we saw earlier, then that's not a problem. So we've got the connection open. We've set the request property for the header. Now we need to output the data that are the parameters that belong to this request. So we need an output stream. We're going to use a data output stream. We're calling it out, and it's going to be set to be a new data output stream that uses the connections output stream. So essentially it wraps it up so that we can do useful things. Rather than sending byte at a time, we can call write bytes, and that will just take a string and output it. That string has to contain all the parameter information. So we've only got one bit of information, that's the name. So we can say name equals, and then we get from the text field the text that was typed by the user. So what we'll end up with, let's say the user typed Graham, then what we would end up with is a string that said name equals Graham. And that can be sent to the internet application. And that's done by calling flush, which forces all the data that's in this data stream to be written over to the application, and then we can close the output stream. We're only allowed one write, so we have to make sure that we write everything in that one operation. So if we've got more than one parameter, we'll have to set it all up in this string here. So we would need an ampersand, age equals whatever value that happens to be, or if we've got a text field containing it, then text fields give it to us as a string, so we could just simply get the age tf.get text. And then that would give us ampersand age equals, and then whatever the value was that was typed by the user. Now, what about validation? If that age text field contains a string that represents an integer, great. And it can just be sent over to the internet application. And of course, the internet application should be doing some validation to make sure that the string that's sent to represent age really does represent an integer. So does the client just rely upon the validation done by the internet application? It could do. But of course, if there's something wrong, then the client has got to write the request over to the application. The application validates, throws up an exception, the controller delegates to the error view, and the error view then sends back in plain text some error message, which will then be displayed. And that's a whole round trip. Request, process, discover the error, write an error message in response. What the client could do, of course, is do the validation before sending the request. That means that all the validation is done client-side, and therefore, when the request does get sent, the application isn't going to have to worry about writing error messages. So does that mean then that we should leave all the validation to the client and never do any validation in the server-side application? And the answer to that has got to be no. Never rely on the client doing the validation, because you might not be writing it. It might be somebody else that's writing the client and just tapping into your internet application. And they might not know what the validation requirements are, and therefore will either put in some weird and wonderful kind of validation or no validation at all. And so because you can't guarantee that the validation will have been done client-side, you've still got to write the validation into the model components server-side. All right, let's undo this so we don't get the compilation errors. Okay. So what we've done here then is set up the request and sent it along with the data for the parameters. Now, as far as the client is concerned, all it has to do now is to sit and wait for the response to come back from the server. And so that's all we're going to do. We're setting up an input stream. So we get from the connection the input stream, and we're wrapping it up first in a buffered input stream and then in a data input stream so that we can store it in the servlet response stream variable. Again, we're doing it in this way so that it's all sort of wrapped up. We don't have to read it a byte at a time. We can read it in convenient chunks. And the next line, 115, does that. From that data input stream called servlet response stream, we're calling readLine. Now that's a deprecated method, which is why it's crossed out. It'll still work, but it's deprecated. There are alternatives. You could, for example, use read UTF, which will return a string. But all we want is to get from the application the response that comes back. So this reads the first line of response and stores it in the variable line. We're then going to set the text in the text area, which was on the right-hand side of the client. We're going to set that to blank, an empty string, And then, while the value of line is not null, in other words, while we're still getting data written to us from the internet application, we're simply going to, first of all, check to make sure that the line length is greater than 0. If you take that if out, when you've downloaded this and you run it, take that if out of the application for a bit. See what happens. You'll be surprised at how many blank lines get written as part of the response. And then you need to ask yourself why. And the answer is going to be in the JavaServer page. It's not that it's an error, it's just that whenever you get some JSP code in there that is being processed server-side, you get a new line written into the output data stream. You can see that if you just look at any one of your applications you've written so far with JavaServer Pages and use the web browser to look at the source code of what's come back to you from the application. And you'll see there's loads and loads of blank lines in there. And try and spot the pattern between what you've got as your source code that the browser has received. Compare that with what the JavaServer page looks like. Anyway, what we're doing with this is just stripping out all these blank lines. And so if the line length is greater than 0, in other words, we've actually got some data in there, then we're going to append whatever value is held in line to the text already displayed in the text area and put a new line on the end of it, so that the text area will eventually display everything that the internet application has sent to it. And once we've finished that while loop, we've received everything that's come from the internet application, and then we can close that data stream. Okay, so other than the setting up of the graphical user interface, this bit here that we've just been looking at, that is all it takes to do a request and response cycle and then display whatever comes back from the internet application. So it is actually quite straightforward. So what if we were doing this as an XML client? Well, let's take a look at the XML client. This is slightly different because we're not going to receive plain text. We're receiving plain text that is XML. And therefore we need to decode all that XML, process the XML document that comes back from the internet application. So again, we've got all this setup stuff, which is exactly the same as the previous example, but the processing of the response is going to be slightly different. So all the connections set up and writing the request, that's all the same as before, so I'm going to skip over that. Reading, it looks actually a lot easier, but it's a little more complicated than before. So what we're going to do is get the input stream and store it in here. We're not buffering it or anything like that, because we're just going to parse it. And we're going to parse it using an XML parser. So here, on line 95, is where we set up the parser. So it's a SAX parser, so it's going to be a simple XML parser. And therefore it's going to take the XML document and just sequentially process it. We're calling the prepare XML parser method, which is this one here. Now what it does is use the class called SAX parser factory, and there's a static method in there called new instance, and we're calling the new instance method that will set up for us a factory, an XML parser factory. From that we can set it to be a validating parser, so that it will take the DTD information that defines the document structure that I was showing you earlier on, and it will use that to validate the XML content to make sure that the content matches the structure defined in the DTD. So we're setting it to be a validating parser, and then we're returning a new SACS parser from that factory. So that then comes back up to here and is stored in the variable called parser. From that variable, line 119, we're calling the parse method, passing in, first of all, the input stream. So it will deal with reading everything that comes back from the internet application. The second parameter that we're passing in is the object that will handle all of the events that are generated by the parser. Now, if you're familiar with event handling, then you'll find this relatively straightforward. If you're not familiar with it, then the basic concept is that the environment will detect some kind of event that occurs and will then generate an event object that needs to deal with it and call a method. That method will be predefined, and I'll show you in a minute how that's done. And the method will then have the code written within it to deal with that event. So my XML parser is actually this inner class here. And it extends default handler. Now, if you were to go and look at the default handler class, you'll find in there a load of event handling methods. And all we're going to do is to override the ones that are of interest to us. Now, I'm going to open up the view file for XML. And we'll look at this side by side. So the root element is message response. That root element in the XML document will be the start of the document, and therefore when the parser encounters that root element, and it knows it's the root element because the DTD up here has said it's the root element, when that root element is encountered, the parser will call start document. And therefore, what our response is to set the text in the text area on our graphical user interface to the empty string. Eventually, when the document has been processed, the parser will meet the end root element and will then call the end document method, at which point the code will append the end message to the text area. The next thing that the parser will encounter is the line element. Now, this is an ordinary element, and therefore it will call start element. And what this method must do is to work out what kind of element it has, because, well, in our example here, we've only got one element type, line. And so we're just going to process it. But we might have more than one element. We might have a student element that contains a name element, an address element, a student reference number element, a date of birth element, and so on. Lots and lots of different elements. Each one of those elements will cause the start element method to be called. And so the code in that method will have to determine what kind of element it's dealing with. And the way that it does it is to make use of one of the parameters, the QName parameter. And that contains, as a string, the name of the element that has just been encountered. In this case, it will contain the string L-I-N-E, line. So if you've got in your XML document lots of elements that you need to process, and they process them differently, then you'll have an if statement in the start element method. If QName dot equals line, then you're going to do one thing. Else, if it equals something else, you're going to do something else, and so on. So all we're going to do here is to say when I'm starting the element, I'm going to report in the text area what element it is. So it'll say line. And then it's going to say display characters, which is a variable. That variable is declared right at the top here. Sorry, where is it? No, it's declared here in the handler at the top of the inner class. It's a Boolean variable, and if set to false, well, you'll see what happens when it's false and when it's true. What we're going to do then is to say display characters needs to be set to true if QName is line and false otherwise. Now why? Well, why is because having processed in the XML document the start element, it's then going to find whatever comes out of that particular JSP line, which is going to be hello unknown person or hello Graham or whatever the user typed. So it's going to receive characters. When the parser encounters those characters, it will call the characters method, passing those characters as an array of char values, and will tell us the start and length, the index that is of the start here, and the length of the number of string, the length of the string essentially. So then this method will test if display characters is true, then we're going to convert this character array into a string, trim it. If its length is greater than 0, then we will append its value. So it will then append to the text area, hello Graham, hello unknown person, hello whoever you are. The next thing that's encountered in the document is the end line element. So end element is called, and it's going to output again QName. Well, QName is going to be /line. And, sorry, it might actually just be line. And then display characters is set back to false. The next element is encountered, so start element is called again. Display characters is set equal to be, well, to true if this is the line element and false otherwise. And then it will display, because characters is called, the time on the server is whatever the value happens to be. Okay, so that's how the parser will deal with these things. Now, if you've got more elements, then you're going to have to be a little bit more careful, because not only do you have to work out what you're going to do with a start element, but you're also going to have to work out in here what you're going to do with the characters that belong to the element. So you might just need to be a bit inventive, a bit creative here about how you distinguish between the various element types that you could get. Because characters is always going to be called, and therefore it's in here that you're going to have to work out what kind of element these characters belong to. And that's going to be determined really by what you do up there. So you might have a whole load of Boolean variables that can be set in here, so that down there you can test to see what kind of element you're dealing with. Okay, so that's essentially how an XML document is processed. It comes to us from the server as the input stream, which is parsed using this parser to process the XML document. Once that's all been done, we close the input, and all the processing of the document has already been done by all the methods down in here. So essentially that's the end of processing that element. Right, a couple more points. We're writing these applications as standalone Java applications, but they don't lend themselves to distribution around the world. You can't just say, oh, here, have a copy of my application and run it. It's not that easy. unless you want to receive hundreds and thousands of emails from people all over the world saying, please give me a copy of your application. So you don't want to do that. That's not the best way. What you can do instead is to make use of the Java Network Launch Protocol, JNNLP. And that allows you to put your application on the web server and distribute it at will, at the request of the users. Also known as WebStart, and these days it always ships as part of the Java runtime environment, and therefore we have the capability of distributing and launching a Java application across a network, including the internet. And so what we do is set up a JNNLP file, which is an XML file, which defines the location of a jar file, Java archive file, that contains all the application's classes. It also contains the name of the main class and some other parameters. And when you download the applications, let's just close these now. Having set up those applications, let's discard that. Back in here, you'll also find that they launch with the JNNLP. Sorry, that's in the way. Let's close that for now and focus on these two application projects. I've done the same in both, so I'll just pick this one. We go to the project properties, and you'll see in the project properties that we've got WebStart. If you go into there, you can tick this to enable WebStart, which means that NetBeans will automatically set up the jar file and the JNNLP file and an HTML file so that you've got all the bits and pieces you need. And you've got various options here that you can play around with and see how they all work. I'm just going to work on the local execution for ease of this. So once that's all been set up, you can then build the application. And then when you've built it, let's take a look in the files here. When you've built it, you'll get a build, which contains all the classes and things, and a dist folder. The dist folder contains the jar file with all the class files for this application, a JNNLP file, and an HTML file. Let's open up the HTML file. The HTML file has got, for your use, for local deployment, this JavaScript. But if you wanted to do it with a web deployment, such as a hyperlink, then you can uncomment that. And basically what it does in both cases is hit the JNNLP file. So in the JNNLP file we have some standard information at the top here. You've got the code base, which tells you the location on the web, or in this case the local file system, of the application, the name of the JNNLP file. We've got some information about that application, such as what it's called, who the vendor is, and so on. We've also got in here, in the resources element, the version of Java that we're using, and also the URL for the jar file. And it has a main method, so a main class actually. And therefore, after the resources section, we have to describe in the application desk element what the main class is. And so we specify the name of that main class. That is the class with the main method. And then when this is launched, the jar file will be downloaded, and the runtime environment will set up an application window essentially, and will then invoke the main method of this class. And that's what happened when I ran this previously. So let's run it again. Now that happened a lot quicker because all the startup for Web Start has already been done. But you can see just here there's a little triangle that says this is a Java application window. That's your clue that this actually has been launched using the Java Network Launch Protocol. So now you can put all your applications, all those files and that we were looking at before, the jar file, the HTML file, the JNNLP file, put those in the same folder on a web server, and your clients can use the application. Just a word of warning, if you set this up, as I have done for this example, as local execution, you can't then just copy that lot straight into a web folder and expect it to work. You're going to have to go for the web launch options when you go into the project properties. That can be a little bit tricky, but play around with it a bit and you'll find that it works out okay in the end. And that rather lengthy explanation is how we can set up Java applications as clients for our internet applications. Enjoy the tutorial.